We're in the middle of this busy highway to talk about one of the measures of central tendency used in data analysis. There are three of them: the mean, the median, and the mode. The mean is found by adding all the items in a set of data and dividing by the number of items in the set. It's the measure people often call the average. The mode is simply the data item or items that appear the most in a set of data. But today we'll focus on the median. Just like this median strip is the middle of the road, the median of a set of data is the middle number in the set. I have my trusty radar gun with me, and I'm going to check the speed of some of the cars that are passing by, and I'll use that data to demonstrate the median, as well as a way to construct a diagram to represent a set of data. I checked the speed of 9 cars that passed me as I was standing out there. The 10th car was a police car, and the officer told me it wasn't a good idea to stand in the road, so kids, don't try this at home. Anyway, I listed the results, and here they are. The first car was traveling 47 miles per hour, the second one 54 miles per hour, and so forth in the order that they drove by. But before we can do anything with the data, we have to arrange it in numerical order. We can determine the range of this set. No, not that kind of range.
Home, home on the range.
Not that one either. I'm talking about the difference we get by subtracting the least value of the set, 39, from the greatest value, 61. The range is 22. To determine the median, we have to count the number of items in the set. There are 9 numbers in this set, so the 5th number is the middle number. That's 47. So 47 is the median of this set. The median breaks the set into 2 equal sets. Oftentimes, statisticians wish to break a set into 4 equal subsets by finding 3 values called the quartiles. The quartiles are often labeled Q1, Q2, and Q3. Q2 is the median. Q1 is called the lower quartile and is the median of the lower half of the data. Q3 is called the upper quartile and is the median of the upper half of the data. You'll notice that there is an even amount of numbers in the lower and upper halves of the data, so the quartiles will not be data points in the set. To find the median of an even set of numbers, you must find the mean of the 2 middle numbers. 43 and 45 are the middle numbers in the lower half, so we add them and divide by 2, so the lower quartile is 44. Similarly, 49 and 54 are the middle numbers of the upper half. Add them and divide by 2 to get the median of the upper half, which is the upper quartile. That's 51 and 5/10. We now have the data divided into 4 subsets. With this information, we can find the interquartile range of this set. The interquartile range is the difference between the upper quartile and the lower quartile. In this case, 51 and 5/10 minus 44 is equal to 7 and 5/10. So the interquartile range, the range of the middle 50% of the data, is 7 and 5/10. We can take all this information and display it in what is known as a box and whiskers plot. No, that's my cat Whiskers. I'm talking about a diagram for displaying data. That's it. The box represents the middle 50% of the data. The vertical line in the box at 47 is the median. The ends of the box, 44 and 51 and 5/10, are the lower and upper quartiles. The lines on the ends, or the whiskers, represent the lower 25% and upper 25% of the data, with the bullets on the ends being the extreme values. You can make observations about the data from the box and whiskers plot. For example, you can see that the whisker and box from the top half of the data is longer than from the lower half. That would indicate that the upper half of the data is more spread out or shows greater variation than the lower half of the data. We can see from the plot that the bottom 50% of the data has less variation than the top. In other words, the bottom 50% of the speeds went from 39 to 47, but the top 50% of the speeds went from 47 to 61. Now, if we know the speed limit is, say, 45, then we know that more than 50% of the drivers were speeding. It's also important to note that the box and whisker plot does not tell us any individual data points. We lose that information when we draw the graph. Now, we only know where the different sections of the data lie, so we can talk about the lower 25% or the middle 50% and so forth. Remember, even the quartiles aren't necessarily data points. Using the concepts of median, range, quartiles, interquartile range, and box and whisker plots, not you whiskers, you have the tools to analyze and compare sets of data. Now, you be good or back in the box for you. Don't dig into me, please. Ouch, ow, ow.